Rise and shine, Educalidad. Great morning, students and dear listeners. Welcome to our class on air here in DXVD 101.3 FM. This is teacher Sherry May from the Pitan City National High School for grade 9 science lesson for the week 2 of January 2021. Grade 9 students, are you ready? In this session, let's study how atoms form chemical bond, their way to achieve a stable outer electron shell or valence electrons configuration, which results to the production of many compounds. Before that, let's get introduced what valence electrons are. Valence electrons are the outermost shell electrons, and they are the ones that participate in chemical bonding. The number of valence electrons determine how atoms behave. If an atom has 8 valence electrons, just like the noble gases, they are stable. Only noble gases naturally possess a stable electron shell configuration that includes a perfect balance and distance between the positive protons and the negative protons. Stable atoms, like the noble gases, are inert or not reactive. If an atom has less than 8 valence electrons, the tendency is it will gain, lose, or share its valence electrons in an attempt to fill its outer shell with the 8 electrons to become stable. Except the noble gases, generally, all atoms react to obtain a stable and full outer electron configuration. Thus, electrons are transferred or shared in such a way that each atom acquires a stable electronic configuration, one with 8 outer shell electrons or an octet. Metals or metallic atoms tend to lose electrons due to their low ionization energy and form positive ions or cations, while the non-metallic atoms tend to gain electrons due to their high electron affinity, thus forming negative ions or what we call the anions. Now, what is a chemical bond? A chemical bond is a type of attractive force that forms between atoms. And why do chemical bonds form? So what's the reason why atoms form chemical bond? The reason is to obtain a stable and full outer electron configuration. So what do we mean by a stable and full outer electron configuration? When we say stable and full outer electron configuration, meaning the atom has 8 valence electrons, or it has 8 outermost shell electron, or the valence electron. Generally, there are 3 types of chemical bond. Number 1, we have the metallic. So when we say metallic bond, this is a metal to metal bond. Number 2, we have the ionic bond. This is a metal to non-metal bond. And number 3, the covalent bond. And this is a non-metal to another non-metal bond. The key difference between the bonds is in the nature of the positive and negative attraction. The chemical bond that is formed by atoms can be also classified based on the electronegativity difference. If the difference in electronegativity is greater than or equal to 2, there would be a transfer of electrons rather than sharing of electrons, and an ionic band would result rather than a covalent band. Based on electronegativity difference, generally, the ionic band results when the electronegativity difference is greater than or equal to 2, and the polar covalent bond results when the electronegativity difference is from 0.5 to 1.9, and the non-polar covalent band results when the electronegativity difference is less than or equal to 0.4. Again, if the difference in electronegativity is greater than or equal to 2, there would be ionic bond, and if the difference is from 0.5 to 1.9, there would be polar covalent band, and if the difference is less than 0.4 or equal to 0.4, there would be non-polar covalent bond. When we say electronegativity, so this is the tendency or the ability of an atom to attract shared electrons. Generally, the greater the electronegativity of an atom, the stronger is its ability to attract shared electrons. Metals are more electronegative than metals, meaning non-metals attract more shared electrons than metals do because they are more electronegative or they have higher electronegativity. Now let's take the case the bonds formed by hydrogen with electronegativity of 2.1 and chlorine with electronegativity of 3.0. So again, we have two atoms here, hydrogen with electronegativity of 2.1 and chlorine atom with electronegativity of 3.0. So to find the electronegativity difference, we just subtract the two electronegativity values, which are 3.0 minus 2.1, and the result is 0.9. So based on our electronegativity reference, the result 0.9 indicates a polar covalent band, meaning the band formed by hydrogen and chlorine is a polar covalent band. How about sodium and chlorine? So what is the type of band formed by sodium and chlorine? So from the periodic table, sodium has an electronegativity of 0.9 and chlorine has an electronegativity of 3.0. The difference between the two electronegativities is 3.0 minus 0.9 is equal to 2.1. This difference indicates that the bond formed by sodium and chlorine is ionic bond. Do remember, ionic bond has an electronegativity difference that is greater than or equal to 2.0. Polar covalent band has an electronegativity difference of 0.5 to 1.9, and for the non-polar covalent band, it has an electronegativity difference of less than or equal to 0.4. So to determine what type of band is formed by atoms, so we just find their electronegativity difference. So where can we find the electronegativity value? Of course, in the periodic table. Again, electronegativity values of the atom are given in the periodic table. Now let's proceed to ionic band. So what is an ionic band? So this is the band formed between two ions by the transfer of electrons. Take note, the word transfer of electrons. So this band involves the transfer of electrons. So from the metal to the non-metals. So when there is transfer of electrons from the metal to the metal, we call this one ionic band. Again, in ionic band, metals or the metallic atoms lose electrons to match the number of valence electrons of their nearest noble gas, and they form positive ions. Positive ions or cations form when the number of electrons are less than the number of protons. Take note, in positive ions or cations, the number of electrons are less than the number of protons. For the group 1 metals in the periodic table, which is the alkali metals, so they have an ion charge of positive 1 or 1 positive. So the ion charge of 1 positive means that the atoms have an excess of 1 proton. That is why the charge is positive 1. The group 2 metals in the periodic table or the alkaline earth metals have an ion charge of 2 positive. Ion charge of 2 positive means that they have an excess of 2 protons. For example, the sodium atom in group 1 metals or the alkali metals. So sodium atom once become a positive ion or cation, so it will have a charge of positive 1. So the notation is Na with superscript positive 1 or 1 positive. So the charge that is 1 positive indicates that the sodium has an extra of 1 proton. So what are some typical ions with positive charge or cation? So we have the group 1, we have the hydrogen ion, we have the lithium ion, the sodium ion, and the potassium ion. So all their charge is 1 positive. So meaning to say that they have 1 extra proton. How about for the group 2 metals? We have the magnesium ion, the calcium ion, the strontium ion, and the barium ion. So all their charges are 2 positive because this group of ions here are having extra of 2 protons. For the group 13 metals, so we have the aluminum ion, charge of 3 positive. So meaning aluminum ion has an extra of 3 protons. Always remember that in cations, the proton number is greater than the electron number because the metal ions are giving off their valence electrons to the non-metallic atoms. That is the reason why their protons are in excess or greater than the electron number. Generally, for metallic atoms, the number of valence electron is equal to their group number, or the group number determines the number of their valence electron. For example, number of valence electron in sodium. So sodium has 1 valence. electron because it belongs to group 1. And what is the number of electron it will lose? Of course, it will lose 1 electron. And since it will lose 1 electron, it will acquire a 1 positive charge to indicate that it has an extra or an excess of 1 proton. So why is there an extra or an excess of proton in sodium? 1 proton in sodium because sodium is giving up 1 of its electron, and that is the 1 valence electron. That is why the number of electron and proton now becomes imbalance. More on proton and less on electron because 1 electron is given off. So there is an excess of 1 proton because initially in a neutral atom, the proton and electron number are equal. Let's try this activity. So give the ionic charge for each of the following. Number 1, 12 protons and 10 electrons. So in this example, proton number is greater than the electron number. So again, 12 protons and 10 electrons. So the answer is 2 positive. Why? Because there is excess of 2 protons. How about if there are 50 protons and 46 electrons? Again, 50 protons and 46 electrons. So what is the ionic charge for the metallic atom or metallic ion or the cation? The answer is 4 positive. Why? Because there are 4 more protons in the atom. So take note, if the proton number is greater than the electron number, the ionic charge is equal to the difference of the 2 number of electron and proton, and it is always positive. Non-metal atoms add electrons to achieve the octet arrangement. Non-metal ionic charge in group 15 is 3 negative, in group 16 is 2 negative, and in group 17 is 1 negative. If the negative charge ion, or what we call the anion, has a 3 negative charge, meaning it has acquired 3 electrons. And if the charge is 2 negative, it means it has acquired 2 electrons. And if the charge is 1 negative, it means it has acquired 1 electron. So in anions or negative charge atom, the charge is equal to the number of the electrons acquired or added to the atom. Again, if the charge is 3 negative, meaning it has 3 more electrons, and if the charge is 2 negative, meaning it has 2 more electrons, and if the charge is 1 negative, it means it has 1 more electron added to the atom. Take the case of the chloride ion. The notation of the chloride ion is Cl1 negative, a superscript. The charge 1 negative indicates that the chloride ion has 1 more electron added in the outer shell. So which means now that the electron number is greater than the proton number because of the presence of the additional electron that is added to the outer shell. Next, the chloride ion to have a charge of 1 negative. Again, when we say ionic band, this is form between atoms of metals and nonmetals with very different electronegativity. And this is the band formed by the transfer of electrons from the metal atom to the non-metal atom. Now, what are the properties of the ionic compounds made from the ionic band? So number one is they have very high melting point and boiling point. Example, table salt melts at 801 degrees Celsius and boils at 1413 degrees Celsius. Number two, the compounds in the solid state of ionic compounds are non-conductors of electricity, but in the molten or liquid state and in aqueous solution or once dissolved in water are conductors of electricity. Blood waters contain many dissolved ionic compounds. Somebody can get electrocuted in case live wires from fallen electrical poles have come in contact with blood waters. Now let's proceed to covalent bond. What is a covalent bond? A covalent bond is formed by the sharing of electrons between nonmetallic elements of the same or similar electronegativity. The sharing of electron pair is equal, and the covalent band that is formed is what we call non-polar covalent band. So when we say non-polar, the sharing of electrons is equal because they have the same or similar electronegativity. Between nonmetallic elements of different electronegativity, the sharing of electron pairs is not equal, and the covalent band that is formed is what we call the polar covalent band. So, in polar covalent band, the sharing of electrons is not equal due to the difference of the electronegativity of the two nonmetallic elements. Diatomic molecules like chlorine gas, oxygen gas, hydrogen gas show non-polar covalent bands, while the water molecule shows the polar covalent band because oxygen molecule is more electronegative than the hydrogen. That is why the difference in electronegativity is bigger, which result to the unequal sharing of the electron pairs. Now, what are the properties of the covalent compounds? Generally, covalent compounds have low melting point, low boiling point, non-conductors, and may be soluble or insoluble in water. Now let's get introduced to naming binary covalent compounds. When we say binary covalent compounds, so this is made of two non-metallic atoms. To name binary covalent compounds, we follow the following procedure. Number one, we write the name of the leftmost element in the chemical formula first. Second, we give the name of the second element an IDE ending. And third, we use the Greek prefixes to indicate the number of atoms of each element. The prefix mono is not used with the first element. In the prefixes ending in A or O, the A or O is often dropped if the name of the second element begins with a vowel. Example, oxide. So when we're going to add mono to oxide, we're going to drop the O of mono, so it becomes monoxide. The different prefixes used in naming binary compounds are, for one, we have mono. For 2, we have di. For 3, we have tri. For 4, tetra. For 5, we have penta. For 6, hexa. For 7, we have hepta. For 8, we have octa. For 9, we have nona. And for 10, we have deca. For example, SO2. So this is sulfur dioxide. CCl4. So this is carbon tetrachloride. For N2O2, so we have dinitrogen tetroxide. And for CO, we have carbon monoxide. How about the chemical formula of the binary compound? So very simple. For example, if the compound is phosphorus trichloride, so the formula is PCl3. So we use the subscript 3 for chlorine because of the word tri, which means 3. Another example, sulfur tetrafluoride. So the chemical formula is SF4. Last example, phosphorus pentoxide. So the chemical formula is PO5. So take note, the number here are written as subscript. Now let's proceed to metallic band. What is a metallic band? Metallic band is formed between atoms of metallic elements. In metallic band, there is a strong attraction between the electron and the cation of a metal. Properties of metals include good conductors of heat and electricity at all states, lustrous, and very high melting point. Examples of this, we have sodium, iron, aluminum, gold, copper, and etc. Take note, metals do not combine with metals. They form alloys, which is a solution of a metal in a metal. Examples of alloys are steel, brass, bronze, and pewter. So to recap, students, there are 3 types of chemical band formed by atoms. So we have number 1, ionic band. This is band between metal and non-metal atoms. Number 2, we have covalent band, band between a non-metal and another non-metal atoms. And number 3, we have the metallic band, a band between a metal and another metal atom. So this is all for today, students, for our science lesson. Thank you very much for your time. For this RBI segment, thank you DepEd Dapitan City, headed by our Superintendent, Dr. Felix Romy Triambolo, and LGU Dapitan City, headed by the City Mayor, Honorable Rosalina Garcia Haloshos. Rise and shine, Educalidad. Stay safe, everyone. Bye-bye.